Welcome to Real-Time Streaming Reliability. I'm Ernest Russell, Technical Product Marketing Manager for Limelight. Real-time streaming for Limelight has several methods to help increase the reliability of our streaming. One is adaptive bitrate, two is temporal thinning, and three is fallback protocols. For adaptive bitrate, an encoder will encode a single video and audio stream into multiple bit rates. The client can switch between these bit rates, so web browsers will switch between bit rates depending on network conditions or the client's device. Limelight RTS does not include transcoding. Each customer must send each bit rate for their stream. Here you'll see differences in resolution for the same picture. To the left, you have a 4K image, and to the right, you have the same image at 480 pixels. The larger the image is, the more recognizable the image quality will be. Now let's talk about web browser ABR behavior. Both HLS and MPEG-Dash have similar ABR algorithms that prioritize video as fast as possible. Same in VP8. This means the quality or initial quality of a video can be lower even if there's bandwidth to download a higher quality file. The player then upswitches to a higher quality as soon as it can without causing a rebuffer event. The algorithm will never request a higher quality that's larger than the video player. This helps save bandwidth and also provides the best user experience. When the size of a video player changes, maybe by maximizing the window, this is an opportunity to scale to a higher or lower quality and adjust accordingly. In 1957, a market researcher named James Vickery inserted the words "eat popcorn and drink Coca-Cola" into a movie. The words appeared for a single frame, allegedly long enough for the subconscious to pick up, but too short for the viewer to be aware of it. The subliminal ad supposedly created an 18.1 increase in Coke sales and a 57.8 increase in popcorn sales. Video gamers and airline pilots have trained their brain to view more frames per second and can recognize a change in image a little bit better than most. Now let's talk about temporal scaling. RTC applications such as VP8 use temporal thinning to quickly adjust data rates to network bandwidth variations. Frames forming each temporal layer can be dropped without affecting the decoding of the lower layers. WebRTC supports at least 3 temporal layers, and using the reference frame or golden frame, they can be implemented or delivered in different ways. The first layer is encoded as previous frames that use previous frames as references, illustrated on the left here by the cake being divided into different layers. Layer 2 is a more advanced frame that uses golden frames as reference and also previous frames as reference and combine those two images. And then finally, we have the third layer that's encoded as non-reference frames that use golden and reference or previous frames as references. So this is a more complete layer. Typical frame rate for the first layer is 7.5 frames per second. The second layer is 15 frames per second, and the full frame rate being 30 frames per second. We want to be able to deliver as many frames per possible, but it's better to deliver at a lower frame rate than not deliver the video at all. Now let's talk about temporal scaling versus adaptive bitrate resolution. In temporal scaling, we change the frame rate or reduce the number of pictures or frames shown per second. This also reduces the bit rate and requires less bandwidth. So a reduction in temporal scaling or frame rate can sometimes result in a choppy picture, as illustrated on the left with a car in constant motion. In 30 frames per second, those images will be smoother versus at a lower frame rate where video can become choppy and the car can seem to jump from one place to another. Adaptive bitrate are changes in resolution. Changes in resolution are changes in the size of the video. And these are handled by the client's video player. And to the right, you'll see the menu in YouTube, which allows you to change your resolution from 720, 480, 360p, 240, or to allow YouTube to auto-adjust those resolutions for you. Temporal scaling versus adaptive bitrate. Which is better? It depends. Temporal scaling is better for video without fast movement. Adaptive bitrate works better for video with fast motion. So adaptive bitrates are handled by the client's video player, while temporal or frame rate changes are usually handled at the encoder and decoder level. And finally, we'll talk about fallback protocols. So to ensure reliability of video delivery, Limelight Real-Time Streaming can fall back to different protocols if the client does not support WebRTC over UDP. To ensure the lowest latency, the preferred delivery for real-time streaming is WebRTC over UDP. If a player cannot use this delivery method, fallback will occur. Limelight Real-Time Streaming can send data to clients over TCP if UDP is blocked. Note that latency will likely increase if fallback occurs. In the HTML SDK, you can specifically target a playback protocol, or you can let the SDK automatically choose a protocol based on the player and browser compatibility. Real-time streaming fallback order can be changed or configured. WebRTC for browsers, including Chrome, Safari, and Firefox, is the first option. If we cannot use that to deliver, we fall back to WebRTC over TCP. Following that, we fall back to HLS over RTMP if WebRTC is not available. And finally, fall back to RTSP for mobile, including iOS and Android devices. So let's talk about browser support for WebRTC. The chart below shows the percentage of browser usage for 2018. Chrome and Safari are the winners by far, composing over 70% of the browser market. Internet Explorer, about 5% of the market, does not support WebRTC currently. Also, the Samsung browser, our fourth place browser winner, is about 3.8% of the market and does not support WebRTC. The browsers that do support WebRTC are Microsoft Edge, Google Chrome, Mozilla Firefox, Safari, Opera, Vivaldi, and also BlackBerry 10, Mobile Safari, and Tizen. That concludes my presentation on real-time streaming reliability. Thank you.